At the end of the topic, you will be able to define distance and displacement, differentiate between distance and displacement, explain uniform motion and non-uniform motion.
Mountains, buildings and towers do not move from their place. They are stationary. These motionless things are in a state of rest. Therefore, all stationary objects which do not move from their place are in a state of rest.
The movement of a body from one place to the other is generally known as motion. Vehicles like bus, car and motorbikes, human beings, animals and insects are some examples for moving objects. Therefore, a body is said to be in motion when there is a change in its position with respect to time.
Suppose if someone asks you, "Where is the post office?" how will you direct them to the post office? You will say the direction as, go straight ahead 3 meters, turn right and go 1 meter, turn left and go on, and the last building is the post office. You might also say that the post office is 5 kilometers and it will take 5 minutes to reach there by car. Therefore, to locate a place, we must specify distance, direction, and time. Following the directions given by you, your friend starts to the post office. Let us consider a body moving along a certain path indicated by O, A, B, C, D. The distance covered by the body is the length of the path along which it has travelled, O, A, B, C, D, and is denoted by S. Distance covered is measured in centimeter or meter. Now, we will see the distance and the displacement with the following example. Suppose AB is the distance to the school from the house. Instead of going straight to school, you go to a shop AD, then to the beach DC, then you reach school CB. Consider 4 towns A, B, C and D at the corners of a quadrilateral as shown in figure. Suppose you are in town A and want to reach a town C. There are 3 ways: A to C directly, A to C via B, and A to C via D. Out of the 3 routes, which is the shortest one? You can easily identify that the direct route from A to C is the shortest. This is called the resultant displacement vector AC. The shortest distance between 2 points is called displacement, or the length of the straight line joining the starting point and end point is called displacement. Suppose a body moves from A to B in a straight line path in a fixed direction. The length of the straight line joining the initial position A and the final position B is called displacement. The displacement of a body is the change in its position in a specified direction. Some of the facts about displacement are: the magnitude of displacement is the length of the line AB and the direction is indicated by the arrow mark. The straight line distance between A to B or B to A is the same. But displacement AB vector is not equal to displacement BA vector, as the body is moving in the opposite direction. AB vector is not equal to BA vector. Displacement has both magnitude and direction, and it is a vector quantity or simply a vector.
Now, Let us differentiate distance and displacement. Distance is the length of the actual path followed by an object or body while moving from one point to another. Displacement is the shortest distance between 2 points. Distance is a scalar quantity having only magnitude. Displacement is a vector quantity having magnitude and direction. Distance is measured in meter in the SI system. Displacement is measured in meter in a particular direction in the SI system. Distance traveled is not a unique quantity and is always path dependent. Displacement is only dependent on the starting point and the ending point and is independent of the path followed. It is unique to a given pair of points. Distance can either be equal to or greater than displacement. Displacement is either equal to or less than the distance. Consider the race between the hare and the tortoise. The data regarding the motion of the two are given in the table. From the data, we notice that the tortoise covers 5 meters in every 5 minutes. It covers the same distance in a particular time throughout its motion. This type of motion is known as uniform motion. If an object covers equal distances in equal intervals of time, it is said to be in uniform motion. The hare in its motion covers different distances in a particular time. The hare in its motion covers different distances in a particular time interval. This type of motion is known as non-uniform motion. If an object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. In this topic, you have learned: distance covered is the length of the path along which the body has travelled, measured in centimeter or meter. Displacement is the shortest distance from the initial position to final position. If an object covers equal distances in equal intervals of time, it is said to be in uniform motion. If an object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. At the end of the topic, you will be able to define speed and velocity, state the differences between speed and velocity, explain acceleration with examples, express the formula and unit of acceleration.
We already know that distance and displacement has distinctly different meanings. In the same way, even speed and velocity are two different physical quantities. Speed refers to the distance traveled by an object per unit time. A fast-moving object covers a relatively large distance in a short period of time. A slow-moving object covers small distance in a short period of time. If we say that the train is running at a speed of 120 kilometers per hour, we can understand the speed of the moving train. We cannot get any information of the direction of motion of the train. So, in order to exactly define the position of the train, we must know the distance traveled in unit time, that is, the speed and the direction of motion. Thus, we have velocity defined as the distance traveled by an object per unit time in a particular direction. It can also be understood as speed of a body in specified direction. Consider a train moving on a curved track at a speed of 60 kilometers per hour. Suppose the train moves exactly 60 kilometers every hour. Then for 1 minute it covers a distance of 1 kilometer exactly. Similarly, in each second it travels distance of 1 by 60 kilometer. Thus, the motion of the train is uniform and it is said to travel with uniform speed. Since the train is traveling on a curved path, its direction of motion is continuously changing, or it has no fixed direction. Therefore, velocity is changing. A body is said to move with uniform speed if it travels equal distances in equal intervals of time. In ordinary conversation, the word velocity and speed are often interchanged. But in science, it is important to distinguish between these two terms. The displacement of a body is the straight line distance OD vector, represented as S vector. Then, velocity is defined as the rate of change of displacement in unit time in a specified direction. Thus, velocity v vector is equal to displacement by time, which is equal to S vector by t. Have you ever been caught in a traffic jam? Consider a car moving through a busy road with a number of signals in between. The motion of a car is not uniform because the car has to slow down at traffic signals. Here, the displacement and the time vary. So speed and velocity both will be varying. Next, we will see the uniform velocity. Consider a body moving in a straight line path. It travels 10 meters in each second so that OA is equal to AB is equal to BC is equal to CD is equal to 10 meters. So, its displacement is the same for each second. Velocity is equal to 10 meters per second towards right. A body is said to move with uniform velocity if it covers equal displacements in equal intervals of time, however small the time interval may be. Uniform velocity is a vector quantity.
Whenever there is a change in the direction of motion, it results in the change of velocity even though there is no increase or decrease of speed. This is due to the fact that velocity is a vector quantity that possesses both magnitude and direction. The rate of change of velocity is referred to acceleration. Acceleration occurs any time an object's speed increases, decreases, or changes direction. Let us learn in detail about acceleration with examples. Have you ever observed a train leaving the station? It starts from rest and picks up its speed gradually. Then the train is said to travel with non-uniform velocity or with acceleration. Let us now consider a train approaching the station. Initially, the train's velocity is high, and as it comes towards the station, its velocity goes on decreasing. Then, the train is said to move with deceleration or retarding acceleration. Finally, it comes to a halt at the station. Retardation is nothing but the negative acceleration. How do we define acceleration? Acceleration is defined as the rate of change of velocity. It is a vector quantity. Mathematically, it could be expressed as follows. Velocity is represented as vector AB. Vector AB is equal to vector OB minus vector OA. Acceleration vector A is equal to vector V minus vector U divided by t. Units of acceleration in CGS system is centimeter per second squared. Units of acceleration in MKS system is meter per second squared.
A body moves with uniform acceleration when it undergoes equal changes in velocity in equal successive intervals of time. If the acceleration of the vehicle is uniform, then the change in velocity of the vehicle is equal, and also the vehicle moves with uniformly changing velocity in equal intervals of time.
In this topic, you have learnt speed is the distance travelled in 1 second. It is measured in meter per second. Velocity is the rate of change of displacement. It is expressed in meter per second.
If a body travels with constant speed covering equal distances in equal intervals of time, we say it has uniform speed. It is a scalar. If a body travels with constant velocity covering equal displacements in equal intervals of time, we say it has uniform velocity.
A body moves with uniform acceleration when it undergoes equal change in velocity in equal successive interval of time.
A graph is a means of representing data that will facilitate a comparative study between a set of data. In kinematics, graphs are used to describe the motion of objects. We could analyze various other data from the graph. Line graphs show dependence of one physical quantity like distance or velocity on another quantity, say time. Some of the graphs that are used to study motion are distance-time graph and velocity-time graph. In these graphs, time is an independent variable that keeps changing. It is always taken along x-axis. Other variables like distance and velocity are dependent variables that depend on time. These dependent variables are always taken along the y-axis. How to represent the motion of a vehicle by a graph? A graph between distance and time helps in the study of body moving with uniform and non-uniform speed and a body at rest. This graph helps us to describe the nature of motion of a body, find the position of the body at an intermediate time, and calculate speed of a moving body. A graph showing variation of velocity with change in time is a velocity-time graph. This graph is used to study motion of bodies traveling with constant velocity, accelerated motion, that is, increasing velocity with time, decelerating motion, that is, decreasing velocity with time, and non-uniformly accelerated motion. From the velocity-time graph, we can determine velocity of a moving body in a particular time, determine the nature of motion, determine the magnitude of acceleration from the slope of the line in velocity-time graph, and determine the total distance traveled by the body in a given time interval. Now, we will try to derive some information from this velocity-time graph of a moving body. From the graph, we can say that OA is the initial velocity of the body. The portion of graph AB indicates that its velocity is increasing uniformly with time, that is, the body is accelerating. So, the body has uniform acceleration. The portion of graph BC shows that the body has traveled with the same or constant velocity for some time. The body has zero or no acceleration. The portion of graph CD shows that the body is decelerating, that is, its velocity is decreasing with time. Consider the motion of a moving car. Let us now see the velocity-time graph of the car when it is moving with constant velocity, when it is speeding up or slowing down.